Okay, so I was saying before we define the architecture, I think it's very important to define what a campus network is, and how it differs from, I think at this level, we mostly deal with my campus network and up to my enterprise networks. Uh, a campus network basically defines a network yakaita kunge we're all pane user students panapa yakaita kunge UZ campus. I don't know, is this why it's called a campus? UZ campus, basically defines a campus network where you have on a small geographical size, multiple buildings, uh, but network yet confined per UZ pub. That is what defines a campus network. Um, Another case, you could have multiple campuses. Tomboti UZ inogonaita campus network iri pa Mount Pleasant. Yoita imwe campus network UZ ine imwe campus here. I don't know. Yoita maybe imwe network iri ku UZ farm. Maybe kumarondera kwangu ne something kwete imwe campus network. The moment where you have multiple campuses like this, it's no longer a campus network. That's a typical enterprise networking where you are connecting multiple sites. But when we talk of a campus network, we are basically looking at one site. Network here confined within that specific site. In this architecture, the way I don't get it up, defined by my layers IO. This one sounds new. We have the access layer, aggregation layer, and the core layers, with the access layer being the one panoconnecta ma-end devices edu. So kunoku ndokune-PCs enyu, ndokunamafoni enyu, ndokune-everything. You access them via those access layer 2 switches. Then the aggregation layer, also called the distribution layer. I think so. Aggregation layer basically being the one which connects multiple access layer switches. So you can see Panapa is usually, it can be my layer 2 or it can be my layer 3 devices and Ngaripo, my layer 3 switches and Ngaripo, which basically connects multiple layer 2 devices. If you look at this one, it's connecting these two switches. Then Panama links akangowanda ipapapo to accommodate what we call redundancy, very important to understand why we have multiple links up. Then you can see tuna ether channel iripo hapo. That's another characteristics yatinayo at the aggregation layer. Then from there we go to the core layer, which is usually the backbone of the network. Uh, this one looks a bit different from what I know, but I think core layer and egress layer, if I look at egress layer, is probably kunosikira our internet, kunosikira our network, egress, the exit interface, exit layer, in this case, exit layer, which connects our internet, our network to the outside world. That's the egress layer. Then with the core layer, but negative core devices add up, which basically forms the backbone of the network, the backbone of our network. So with those layers, that's a typical architecture, a campus network. That's how you set up a campus network yako. Most times though, these two layers, this one, egress layer, believe me, sounds very new. These two layers are usually collapsed and anonzongobatanidzwa ari two. So we end up having a collapsed aggregation and core layer, 22 layers plus the access layer. Right. A layer 2 Ethernet switch, it forwards data. It forwards data through Ethernet interfaces and can address forward data only according to the MAC address, which is in a layer 2 header, Ethernet frame header. All right, so with this one, this is basically there isn't much information, but I think let's move. Working principle of switches, potentially better. I don't see much here. Let's just move to working principle of switches. So we have host one trying to send something to host two. Let me see. MAC address table, flooding, forwarding, discarding. All right, let me break it down like this. Right, working principle of switches is very simple. We have more processes which we need to learn from. We have what we call actually learning. We have what we call the learning process. We have learning, then we have flooding, then we have forwarding, and I'll add some as we go. So to understand the working principle of switch, you need to understand those three processes. We have the learning process, which consists of learning of MAC addresses, adding of MAC addresses to what we call the MAC address table, another term. So we have what we call the MAC address table. So this is a storage in engaged my devices add up from a switch yet not MAC address table. So it's a map between my ports and corresponding MAC addresses, source MAC addresses of my devices on those ports. So for example, the MAC address here panapa it already filled yepa switch not. Inenge ine information yekuti kana tichibva pa port iri gig 001 pane address iri apa. Let's call this X, let's call this Y. Then kana tichibva pa port G002 pane address inonzi Y ish. Then it's MAC address table. So it shows us kuti pa port rakati pane source MAC address yakati yedevice yakati. It's a map of my MAC addresses of all my devices are within our network. So MAC address table yedu is stored on the switch. My entries are kupinda kwawo pa MAC address table. That's the process of learning. We'll break it down shortly. Right, so learning, it concerns the MAC address table and adding of my MAC addresses to the MAC address table. Then we have flooding. You can relate that to broadcasting, where we have an unknown unicast frame. Kana send the information yedu and we don't know the destination MAC address to the public. There is a process in it which ends up with flooding, where frame rate is forwarded, broadcasted to all my ports on our switch so that we can learn kuti rinofana kuenda kupi. That's the process of flooding. Then forwarding is a process yekuti takuziva the destination MAC address, then we forward directly and only to that destination MAC address. Working principle of a switch. Right, I think it's important to understand. I'm seeing process of encapsulation somewhere. It's very important to understand the process of encapsulation. All right. So if I'm trying to send information from host 1 to host 2, my layers edu are 7. Tinotangura ku application layer number 7 tichidzika kusvika kuphysical layer, layer number one. That is what defines the process of encapsulation. But with encapsulation, we are adding extra information to our data. Extra information here, it includes adding my destination IP, source IP, destination MAC address, and source MAC address. That is the process of encapsulation. On the other side, can I talk about from the physical layer connect to the application layer? That's the process of a de-encapsulation. Takuvura our PDUs. Did you know the destination MAC, destination IP? Is it correct? Does it correspond to our devices? So during the process of encapsulation, part of it there were these important things: source MAC, destination MAC, source IP, and destination IP. It means information yangu pari kubva panapa ndo apa painosvika palayer number 3 inoederwa maip, painosvika palayer number 2 yoederwa maMAC, then kana zvese zvaederwa ndoti ikwanise kusendwa through the physical medium kuti iende kumwe kwairi kuenda. Kana tine missing information during encapsulation, that's a problem. Right. So you realize that most times kana ndiri kuda kusenda information via DNS, ndinenge ndiri kutoziva the IP address. IP address is mostly known. So kana ndiri kudhila nema-remote networks, kana ndiri kudhila nema-remote networks, DNS inondiudza the IP address, but haindiudzi the MAC address. This is not a remote network, hayo. This is a local network yatinayo. But mostly, if we're dealing with my remote networks, DNS basa rayo ndiye kundiudza IP. How? Via the domain name ranenge ndiri kushandisa. So IP ndiye ndiri kuiziva, but the destination MAC ndiye ndisiri kuiziva. So you realize kuti this case ndodaisa information uku. My destination yandinoziva ndeiyi rapa iyi. Inotozivikanwa ishi. IP. So per field rangu repanapa, I'm sorted. This is the source actually. Per field red destination IP during encapsulation process yangu and then resorted. Hang on. Natinditangire kumashure bichana so that probably if you understand it, vamashure panaya mubvunzo, you don't feel lost that much. Right. So during process encapsulation, pandinosvika pa destination IP panapa. Zvinoti ndikuisa IP host 2. But pa destination MAC apa iyi inenge isingatozivikanwa iyi, the physical address of our destination patinoita encapsulation yedu. Source MAC ish ndiye host 1 yedu ishi, source IP ish ndiye host 1 yedu ishi. Introduction toisa inonzi ARP cache.
ARP.
Voila. Toisa introduction ARP cache. So we have another memory yatinayo iyi ARP, which consists of my mappings IP neMAC address. So every time pandiri kusenda information from a host, first place yandinotanga kusvika kana ndauda kuisa encapsulation panapa destination apa, ndinotarisa mukashe umu kuti IP yandinayo ishi corresponding MAC address yacho ichi. So initially, in our case, kana ndandisana mbosenda anything, you realize that cache mune musina chinhu because it isn't, we don't have an entry yet. Ndosaka ndati destination MAC address iyi tensiri kutoiziva iyi mukashe umu inenge isitorimo. Right. Kana isimo, enter ARP request. Mukashe kana musina mapping yekuti IP address yedu, the goal ndeyekufila part iyi. kuti ndione kuti destination mark yangu ichi during process encapsulation. Kana isipo part iyoyo, saka information iri kuenda kupi? ARP request zvainoita, it's used kutsvaga kuti destination mark yangu ichi with the corresponding IP address yandinge ndinayo. So basically request yangu ndio inotozotanga kubuda. Request yangu inobuda ine broadcast panapa, destination apa inobuda iri broadcast, in ARP request inenge iri broadcast. So inoendesa ma FFF, ARP request yoenda kuti I have IP address yakadai so within the network, what's the corresponding MAC address? Information inenge broadcast kwa ikauya uko ikauya uko, this will respond, this is my IP and my MAC address is this one. ARP reply yodzoka yobva yaedwa kunoko. Painodzoka ARP reply, cache yedu inobva yaita updated, IP inobva yaita MAC address yayo. IP kana yane MAC address yayo on our cache, it means panapa field redu it finally has something. So process flooding ndo ine ARP request iro ratasenda iro apa ndo pane process flooding apa. Then there's a process learning iyo, probably we skip that. Source MAC address yedu ndikuiziva, port incoming port rangu ndikuriziva, ndo two fields aya dzinoshandiswa kuisa ma entries emutable inonzi MAC address table, ndo two ma entries iwaya. Then another entry yandinokwanisa kuisa parikuiswa ARP reply ichibva kunoko, ndakutoziva kuti kana paport iri incoming port riri incoming port, source mark yangu ndeishi, that's another entry inobva yatoiswa muMAC address table yedu. Zvinoti tatone two ma entries. Process of learning on both ends yaitika, process of flooding yaitika. Now kana flooding yapera, takuchizoita encapsulation yedu iri proper, destination mark yedu tanayo, ndo takuzosenda information kwairi kuenda. I started with the summary. Now a repetition of zvanga tichingotaura, now breaking it down nema slides edu. MAC address table, we've already defined this one. So MAC address table yedu, it's a map yekuti paport rakati what is the incoming source MAC address. So paport iri kune chii kunoko, kune MAC address 1. Paport iri kune chii, kune MAC address 2. Ndio inongozi MAC address table. Its importance ndio inoshandiswa neswitch kuforwarda. So kana MAC address table yangu iri field, kana ndoda send information from host 1 to host 2, panoitika encapsulation ndatarisa maARP cache zvese zvirimo, uyu rangu parinosvika panapa, frame panapa rinosvika panapa, switch inotarisa panapa kuti MAC address 2 iri paport ipi, because panoitwa encapsulation kunoko ndinenge ndine destination IP, ndine source IP, ndinenge ndine destination mark, ndinenge ndine source mark, destination mark, source mark. Destination mark yangu panapa inenge iri mark 2 ish, because ndo kuruda kuenda information yangu kuhost 2. So panosvika information panapa, switch parinoita deencapsulation ndo parinoenda inotarisa panapa kuti destination mark ichi. Ikaona destination mark mark 2 yobva inotarisa mu table, addressing table, kuti mark 2 iri paport rip, yobva inoti iri paport number 2, yobva yaforward the traffic kuenda port number 2. That's the use yeMAC address table. Basically inoshandiswa neswitch kuforward to specific ports. Ma-entries epaMAC address table aya ndo anoonekwa ne the process of learning. The process of learning, I repeat, inoshandisa the incoming port, ingress, plus the source. Ma-questions mamwe anouya achingobvunza kuti ma-entries ari kushandisa chii, not the destination but the source MAC address. Three frame processing behaviors. Flooding, I think inenge iripo pamberi pachaita ARP request. Forwarding, we've gone through that. MAC address table yedu yafilled, takuziva directly kwatinofanira kuendesa information yedu. Then discarding, tomboti waita flooding, wasenda request yako to all ARP request yako to all the ports or broadcast. Asi maports ese acharesponda. The port asi devices ese acharesponda. The device acharesponda is the device in the corresponding IP address. What happens to information I broadcast to other devices is it gets discarded. Basically, it gets dropped. If information doesn't match during de-encapsulation, it gets dropped. Flooding yedu, right, frame sent by host 1, MAC address table searched by switch, frame processing behavior on a switch. If unicast is received, if broadcast is received. Right, flooding yedu, I think key panapa ndo pane ARP request yedu panapa. ARP request yedu, you can see destination yedu panapa. Inenge iri OFs, meaning it's a broadcast. OFs meaning it's a broadcast. What else? Part 2 panapa, we have learned MAC address 1 kuti riri painterface giga ethernet 001. So parosendwa information ARP request yedu painosvika apa ARP request yedu inenge ne source mark ish ichipinda paport iri ndo information iri kushandiswa kuisa first entry yedu panapa. Then tikaenda number 3, if a unicast frame is received, if the switch cannot find the destination mark in the table, the switch flags the unicast frame. That's an unknown unicast frame. If a broadcast frame is received, the switch directly flags the broadcast frame without searching the MAC address table. Two different processes is rip up. Let me see if we can find another slide not to break it down. Those two. Forwarding, frame sent by host, destination MAC. 2, MAC table searched by the switch. 3, frame processing behavior. If a unicast frame is received, if switch finds the destination MAC in the table and the interface number is not the number through which the frame enters over the transmission medium, the switch forwards the unicast frame. My slides edu, they're a bit confusing, but let me see. Forwarding. Pane wakaverengera ACIA yenyu tibrekerere down our slides. Forwarding. Batsira mudzidzisi information.
See, I think iri kuzongopawo like more detail as to my processes my forwarding, flooding, yakungopoka extra in-depth knowledge.
Yeah, ndipe in-depth yacho forwarding zvizikitika. I'm not understanding my slides. Unfortunately, yeah, freestyling inenge iri kuda kunetsa. I'm not getting now the logic yema slides panapa. But you can assist me. Detail yacho iri kuti kudii?
Okay, apo paikutaura ichiti the switch receives a unicast frame and then muMAC address table mayo it then maps kuti destination mark ndine egress uyu port iri rekubuditsa kuenda towards the destination mark. Kana irimo yobva yamecha yobva yaziva kuti this is the interface andinofanira kubudisa nayo, yobva yakanda, yobva yatoendesa yaforward frame.
Okay, sounds simple.
Basically,
It sounds
yeah.
simple. I think ndizo. So forwarding a destination yangu, I know the destination yangu Mark 2. So ndikatarisa patable ndotsvaka kuti Mark 2 riri painterface ripi, then ndobva ndaforward ikoko. It sounds very simple. Pedzisai koapa. What's happening panapa?
Okay, discarding inenge yakuitika usually inonzi app request panoflaggwa switch out of all the interfaces except the one yainenge yareceive. Saka pa-app request apa pa each device iri kutarisa kuti destination mark yakaiswa ndeyangu here. Kana iri yayo ndopainoprocessa yodzosera app reply, but kana isiri it ignores, haidzoseri anything, ndokudiscarda kwacho kwairikuita.
Inocheka destination mark here kana destination IP?
Sorry, destination IP inenge ichida kuti izivise mark yacho, saka inocheka IP address.
Okay, thank you. I think that's it. Then MAC address learning on a switch. Initially, MAC address table is of the switch is empty. I think we've covered this part. Then through the learning process, that's how we have my entries and it's MAC address table here now. Let me see. Learning on a switch. I think this is sort of repetitive. Unfortunately, JCS have covered it in one slide. Now I'm getting confused in my slides essay, but it's sort of repetitive. Let me just repeat in one slide again. Is that the confusion in my slides? Because I think it's the same information. Let's just put it this way. Kana ndichida send the information from host A to host B. Panapa pane MAC address table. Initially empty. So every time pandino send the information, panetwa encapsulation, meaning parodiganwa information about the destination, its IP, and its MAC address. Assuming tinoziva its MAC address, regaimboziva zveARP kudhibhisa. Assuming kuti pandinoita encapsulation yangu panapa, I know the destination IP, I know the destination MAC as well. Zvikureva kuti destination mark inenge iri panapa iMAC address ya B, destination IP inenge iri panapa iIP yedevice B. Information yangu painosvika panapa paswitch up after encapsulation transmission yatoitwa ndasenda, layer 2 device yangu ichafocusa nekutarisa this part, yotarisa kuti B irimo here muMAC address table. Kana isimo ndo panoitika flooding, but we assumed kuti irimo B inenge iripo panapa inenge yakaiswa maport 1 2, B iri paport number 2 inobva yaforwardwa port number 2. Entry iyi kupinda kwayo mutable inenge yapinda ne the process of learning, key term learning. Dai yanga isimo entry iyi paitika flooding because it's in a unknown unicast address, haimo muMAC address table, ndo panoitika flooding. Then pakaitika flooding pane mamwe anodiscardwa. That's another thing. Pakaitika flooding broadcast pane mamwe mapackets anodiscardwa because information panovhurwa encapsulation inenge isiri kuita correspond, is either IP address, MAC address, I mean, it's not corresponding to the destination MAC, or frame information yacho, packet information, for example, kana tichishandisa ARP request, IP address iripo ipapo is not corresponding to the MAC address as well. It gets discarded. Then another term and a serial forwarding. Forwarding ndoyaitika panapa, where we have entry redu ririmo muMAC address table, then we forward information yedu directly to out a specific port. I think it's that simple. A detail mozotipisa mamega, but understanding how a switch works, understand the learning process, understand flooding if we have a non-unicast, or if we have my ARP request aripo, then discarding and forwarding as well. ARP cache, understand that cache inenge iri panapa. We can have ARP cache inenge iri pa device. We can have one inenge iri pa host redu panapa, PC ine cache. We can have another one inenge iri pa switch panapa. So it all depends nekuti which cache are we looking at. Process of data communication within a network. Host 1 wants to access host 2. Host is initialized. In the initialized state, only knows its IP address and MAC address. Assume that the IP address has been obtained. Switch is powered on. Initialized state. We've covered through this. Then encapsulation, we've covered through this. Then initialization, ARP cache. Initially munenge musina chinhu mucache. Kuti tiwane anything ARP process request and reply yet take part. Initially MAC address table yedu haina chinhu. Kuti tiwane chinhu we learn the ingress plus source MAC. Initialization. Flooding frames. Flooding frames is basically broadcasting. Key to broadcasting my FFF akawanda. ARP request by default broadcast is sent out to all ports except the incoming port. The MAC address learning, we are learning about the source MAC and the ingress. We are learning about this one and this one. Send packet here. That's where we learn. Then a reply from target host. We also learn about MAC address ish. Kuti ripa port iri paneswa reply ish. The entry iri rapa. It's another learning process iripo apo. And basically done. That's it. So in summary, what's important is understanding layer 2 switching. Layer 2 switching uses mainly protocol Rhapsody Ethernet, which is the protocol which defines MAC addresses edu. MAC address being a unique identifier, physical identifier of every host, every NIC. Then from there you have to understand could communication, how does a switch work basically? Understanding how a switch work, you have to get the learning, the flooding, the forwarding, and the discarding part. Then you have to understand the MAC address table, how does it work? Tine ARP cache, how does it work? Tine ARP as a protocol itself, how does it work as well? I think here there's also importance in open up understanding every field yatinayo. The OG, it's unfortunate. I couldn't break down this part as much. You are memory bank language. The OG. The one I know is the one at one, which is the type type of protocol inoshandiswa apo. But basically you need to understand every field kuti rinoshandei. You need to understand masizes ayo and their importance into translating the size ye-Ethernet frame redu. You realize kuti I think the focus iri pa-Ethernet frame, but you realize kuti tine mamwe maframes asiri Ethernet. When we're talking layer 2 protocols, it's not only Ethernet yatinayo. We also have mama protocols like layer 2 I know of point-to-point protocol. Rine frame raro rine a bit different from rine different sizes. Well, I'm not so sure about my maximum transmission is we also have HDLC. That's another protocol. A frame relay, that's another protocol in ShansWap. An token, my traditional, my protocols sekudhara. Zviripo ipapo. Zvinenge zvine different sizes as well. But here we're just focusing on the Ethernet because that's the most common layer 2 protocol ratinoshandisa. So I was saying it's important understanding every field. It's important understanding the issue to do with size. It's also important understanding kuti masizes edu kana ari less than 64 bytes or kana ari more than 1518. What does that mean? Ma-array one. We can have my giants, we can have my runs. And basically that's it for this one. Is very simple. That's it for Ethernet switching. Danko. Quiz. A layer 2 Ethernet switch generates a MAC address table entry based on the source MAC address. A switch has 8 interfaces. A Unicast frame enters the switch through one of the 8 interfaces, but the switch cannot find the destination MAC entry in the table. In this case, which one of the following operations is performed by the switch? Flooding. If we cannot find the destination MAC, then Trinidad process is flooding. Very simple. Any questions? Yeah, this one was simple, no questions.